represents Trimble's federal and government infrastructure solutions for the Americas and has a key role as part of Trimble's partner collaborations, working with DOTs and contractors across the country to help facilitate 3D construction workflows aided by various Trimble technologies. And we also have Ron Gant. He is a registered professional engineer in Texas. Ron worked 13 years in the electrical utility industry as a design and construction engineer on fossil and nuclear power projects. In 1990, Ron joined Intergraph Corporation. He moved to Bentley in 2000 when Bentley acquired Intergraph's civil products. For over 26 years, Ron managed technical marketing or sales, technical marketing or sales organizations for Bentley civil products. Ron joined Infotech in 2016. Ron is Infotech's SME for BIM and digital project delivery and serves as a senior business consultant for Infotech and account manager for DOTs in the Southeast United States. Please give a welcome round of applause.
I don't know if I really need this thing, but I'll use it anyway, so the ones in the back can get a translator for my slight southern accent that I have. I really appreciate Adrian letting me be a part of the presentation with me, because he's a smart guy up here. I'm just going to ramble for a few minutes about things. But probably about a year ago, I heard Adrian do a presentation where he made a transition from talking about the common data environment to the connected data environment. And it really resonated with me because of what we're doing and what I've seen Trimble do, that it's a connected environment that we're working in, and not necessarily a common environment. So being true to what I do a lot of times, I stole the phrase, and since I stole it from him, I thought it was only appropriate that when I did a presentation with him, we actually give Adrian credit for what I stole. And we probably pretty far along now understanding that, man, we are in a digital transformation within our industry. And to be honest, we've been going through that for a long time, and it seems to be accelerating. You know, I started on the technology side of this thing in 1990, and we thought we were pretty cool doing our first basic 3D models and competing with Alec back there in those days and stuff like that. And we had a lot of fun, doing those things. And we really thought we were moving the needle a whole lot. And one of the reasons I'm still working, because I'm probably the oldest person by a long shot in this room.
No.
We'll take that wager in a few minutes. Okay, I got a $100 bill laying here. But I love it. Okay, in case y'all didn't know, this was reserved for the hecklers. Okay, so you're not allowed to heckle unless you're at this table. So everybody move forward now. Okay. But we really are accelerating. And this is, to me, I think, the most exciting time to be in our industry today, because we are so close to doing what we've been promising for, in my case, 33 years, we've been promising to do some of this. Along the way, there was a vendor that stepped forward and said, you can model the entire world in our database. And so the future is one giant database, and you're going to put it all in this one giant database. Now, I'm not one to call names Oracle, but they probably can, okay? They've got a great system, and they can a whole lot of stuff. But my question always was, how in the world can an individual consume, manage, handle all the information in one place at one time, and be able to do proper governance and stuff on that? And this came along as a little small company. That, through the use of some internet standards and stuff like that everybody agreed upon, they came up with this idea where we can take data from anywhere and go get what you need, when you ask for it, how you want it, reassemble it into a way that you can understand it. And Google did a wonderful job of really transforming our internet, Mr. Cole's internet, and moving that forward into something that is incredibly useful to us, and probably a lot of times what we refer to as the Internet of Things within that. But that's federated data, and federated data is just another way of saying connected data, because you leave data where it should be and where it should be. But Google could not accomplish that if they didn't have all the standards for So one of the things that we have to have in engineering is we've got to have the standards in order to be able to communicate and in order to be able to bring the right information to the right people at the right time and be able to use this stuff effectively within our jobs. And we've got a lot of different people working on standards. And I always used to joke about the most wonderful thing about the DATs and standards. We got lots of them. We got a minimum of 50. And some politicians may say we have 57 states. But we got, oh, by the way, I do throw politics in there, so if you're sensitive to politics, you might want to leave the room. Or move to the heckling table. Okay. Two choices on that. But we've got a lot of standards that are evolving. They are wonderful standards for us, and there's going to be several presentations throughout the week discussing some of these standards. But, in the facility management space, COVID came along a number of years ago, really kind of revolutionized a lot of facility management, especially for the federal government or what they're doing. But we also, BIM's not a new term. BIM's been around. I think my first BIM project I worked on was in the UK, probably was 16 years ago. And so it's not new, but the processes and having standard processes and being able to do things in a repeatable method really provides that. And we have the IFC, and you should all know what IFC is now, Industry Foundation classes. And it's a new evolving standard for us. 4.3 should be released completely by the end of this year. ISO certification. It's going to be a wonderful thing for us. But Ron gave me a soapbox here a little bit for it. IFC is a wonderful thing. It's a necessary evil. Because if Ron ruled the world, we would all have open APIs, and all vendors would communicate your data to you in an open fashion, and they could all get along and all share data automatically. Unfortunately, it's a highly competitive world. That's what makes us the United States as well, as the competition makes our economy grow. So it's competition, so we're never going to have all these wonderful open APIs that we really need to be able to do that. So something like IFC is necessary to be able to communicate, to be able to archive, to be able to ensure that you have your data, access to your data 40 years from now when some of the big vendors are no longer around. And then, of course, we have the evolving digital twins and things like that. So for a small company like us, we can't do everything. Infotech, we're based in Gainesville, Florida. And I will not say that word, I'll say Health State. I won't mention that ball club out of Gainesville. Talk about competition. But we're based in Gainesville. We're a small company. We can't do all things. Companies like Trimble, they have the bandwidth. They can do a lot of things. And we'll talk about some of the great things that Trimble can do in this thing. But we got to have partners. We got to have friends. We got to have cooperation. We got to have collaboration among other vendors. And these are a few of the other vendors that we are working with. And we've got a couple of new projects that are going on that just started. I haven't updated slide. We're working also with Autodesk and Bentley as well within energy, which is essential for all of us to work with those because they are CAD of choice for all the DOTs. So we really have to be in a situation where we kind of focus and stay in our lane in construction and bidding, solicitation. That's our lane. In order to provide that collaborative product to you for everything that you do, because you're no longer building a project, you're building an asset. And I don't know about you, but I'm from rural Mississippi, and my hometown's got the largest earthen dam in the United States, built in 1954. They rerouted the highway because they took up the highway. I'm still driving on the bridges that they put in place in 1954 to reroute the traffic around the huge lake they built in that little small town. So those bridges are almost 70 years old. And they're the same bridges now. They're replacing a few of them this year. But that's what we're building assets. We're building infrastructure that's got to live our lifetime. Okay? And we're not just doing projects. So collaborating and working together is really important. So some of the ways that we are working together, that we're providing this connected data, this connected environment, is one of the things that we have done with Trimble, with the help of Trimble, and some of their open data structures that they have in their product, is that we started looking at the precision market, how we get precision location information into our construction management products, into the ones that we develop for ASHTO, how we do that. And we're not the precision people. We didn't need to go hire our staff to be able to do all the geodesy to be able to do. So it was natural that we go and partner with Trimble, and Trimble was very open to allowing a small company like us to come in and play in their field and provide information so that we can provide a connection for the inspectors in the field so you can bring precision data using Trimble equipment and bring it into our Apple product, which is the construction administration product for local government, or for the ASHTO product that all of the states, almost looking at this all in the room, I think all of the states use some part of ASHTO or a project in that. And so this connection we made Trimble allowed us to be able to do that, to use precision data. And we didn't have to go develop ourselves. We just had to connect to Trimble, and Trimble connect to us, provide a connected environment to allow you to be able to do that in the same workflow. Now, to be honest, Trimble was the first one. They were the easiest to work with, but we've also done that with Leica. We're talking to another vendor as well about possibly doing that because as a small company, we won't connect with all the big guys that we can. We need to. Within that, to survive, we need to be connected with all of the other folks there. And then, there's this company out there that probably owns 99.9% of the GIS in this country. And when you get all this fabulous data that you create in construction and design, you need to be able to visualize that in a way that even your constituents can understand that, and even your upper management wants to be able to understand what the progress is in your project and how you be able to do that. And so we made connections to ESRI or ESRI to allow you to visualize your construction progress, your construction projects, and different things within the field to be able to do that. So it's only natural to make that type of connection. And then through Trimble, we developed another site. I don't know if Joe's in there. I don't see Joe. Oh, that's right, you're your Simon. Yeah, so we developed another relationship with Simon. Simon does they are the largest reseller for Trimble, I believe, and one of the largest resellers for Autodesk. They are a really fabulous company, and they got development resources. And they really know the Esri and CAD and Trimble world. And so they did some development with us in order to be able to integrate Esri's field maps with our active product line and be able to connect those tools together so that you're working all the way through a consolidated way to do that. And provide visualization in the construction market in a simple way that even your manager can understand what you're doing. And so make it real nice and simple. Now, as we look at this connected environment and being able to do that, the one area that kind of hit us has kind of been lost out there that nobody has paid a lot of attention to. And you're hearing a lot about it, and people refer to, and I hope I don't step on George's toes too hard on this one, but you hear a lot about a model as a legal document, okay? And I heard a lady at an IFC conference a few weeks ago change that vernacular to model as a legal delivery. I like that terminology, okay? Because it's actually part of your delivery, part of the delivery of your contract. So if it's part of your delivery contract, and you're going to have to bid off of it, how are you going to be able to do your bid on a model when you get there? Are you going to have to be a microstation, open road designer, civil 3D expert to be able to bid? Your big contractors, they got the people that can do it. What about all your subs? How are you going to be able to do that? So I beat Mr. Andy to death about the fact we need a way to start looking at viewing models in the bidding environment. How in the world can we do that? And so Andy and team went out and developed a tool, and this is a prototype. It's nowhere near ready for market yet. This is where we play sometimes and do that. I want to be able to bring any model published to IFC and be able to view it in the bidding environment and be able to use that model to do my bids. And so we developed a viewer, IFC viewer, okay? And we've got models from Trimble technical that we use as examples in this. I've got all the models going to come up here in a second in a little video that we use to review. I've got some HDRs providing some Bentley models as well. And I forget who I got the Autodesk models from. You remember we got those from Bentley? We've got some Civil 3D models as well. But if you put the information in your IFC, we can query that model and find that information in the IFC model and provide it to you in a simple web-based viewer to be able to potentially use this in the bidding environment. So that, and the long-term goal is to give you the query and measure, the takeoff type tools that you need in a viewing environment. Now, true, people like HEEP may never need something like this because they have Autodesk and Bentley experts on staff that can dissect a Bentley or Autodesk model, but they're subs. You know, one of the things you hear complaints about subs, I don't have time to train a person on these sophisticated design tools. And so the idea is here to give everybody a browser that you can come in and query this. And we show this to Trimble and all like that, and we think this is a way in the bidding world what we need to do. And Trimble's got some other tools that they do as well. And the great thing about working with people, we do compete with Trimble in a couple of places. But we identify those areas that we compete, and we do this with all the people we partner with. We identify those areas that we compete in, and we tiptoe around one another and play amongst them. But we're all professionals, so there's no reason why we can't get together. But you see in this, if you come in and actually see all the IFC attribution. Now, let's be honest, this is only as good as you make the model that you export from your design. So you got to export a good, solid model for this to be useful. But it also shows you all the attribution that the CAD model is put within that as well. So this is kind of just a little prototype that we're working on. And as part of look at that future, that vision of what we're trying to build toward, Adrian's going to share some of that with you as well. And a key part of that vision being able to do that, is one of the things that I hear a lot is that AstroWare is a closed environment. AstroWare is not a closed environment. There are APIs available in AstroWare. It does run in a relational database, and you as a DOT on that data. So there are ways, we prefer that you come through Astro, through us, to be able to make those connections into the model, but we can connect, and I'm doing a presentation with MnDOT tomorrow afternoon at 4 o'clock, shows you things that we're working on Connect, some tools together. We're doing some things in both the Bentley and Autodesk states to connect AstroWare with your design tools to be able to do the full connectivity and the full digital workflow that you need to be doing within this. So I'm going to shut up and turn it over to the smart guy and say something a lot more useful than what I have to say. But Adrian, the floor is yours.
Thanks, Ron. So what my goal here really is to elaborate a little bit more on what we're defining as the connected data environment. So, like Ron said, it's really our take on the common data environment, but because what it's doing is actually connecting the office to the field and all the core components that are a part of a digital delivery process. So, really, that's what I'm hoping to give you enough information to be dangerous about all of the, or at least some of the tools that are a part of that, and really what the end goal is and why we're doing this and why we're actually calling it a connected environment. And really part of it is, it's an extension of the common data environment. In other words, we're taking that centralized data repository, we're able to then ensure that we're utilizing that information in the field. But a core component is that we're breaking it down into objects. And those objects is what really differentiates the standard sort of file and folder-based workflow to one that is much more highly configurable, and where we can segment the actual process and then actually use that in part of the field solutions. And that'll become a little bit clearer as we touch on those aspects. So Ron already mentioned about some of the APIs, so that's really a core component here. So having access to that data and then also being able to use the best solution or other applications for those, for what you're needing is really the key aspect here of using APIs. So we can have that data there, we can have it, we need to be able to access it, but you obviously want to be able to use it in your native program. So we at Trimble here, we call our APIs connectors. Everyone else has a different name for those, but they're fundamentally the same thing. It's a bidirectional link between an open database or an object-oriented database to the native software, which enables you to design whatever you need to in your design package, push it into the database, and then be able to have it pushed out to the field and consumed by the machines that are actually constructing the project. And then, of course, the nice added benefit there is that data set then becomes the digital as-built. So the nice thing about those connectors being bidirectional is, of course, we can push any of those design changes back to the original designs if we need to. Important point to note, if we are dealing with a model as a legal document, you know, what we're dealing with is a design that doesn't change. But then, of course, we have additions to that design, so you can always refer back to it. That's really the nice part about having all that information accessible within a database. One of the other key aspects of those APIs is that we're able to better understand the data at its core. And so one of the things that we're able to do here is, whilst this just looks like a spreadsheet here, what we're able to do here is take the CAD standards for a state, apply that into what we call conversion rules. And this is where we're actually looking at the data within the DGM libraries, or the feature definitions, and then we're associating those within objects, or as objects within the database. That's a really big difference between you know, just using a standard workflow. The nice part about that, or added benefit, is that we're actually using those CAD standards almost as a validation. So in other words, we're taking those standards, we're using them as part of the template, or we're calling it templatization for each state, so that then you're able to read those by using those CAD standards. It's associating those attributes within objects within the database, and that'll become a little bit clearer as we get into it. And the benefit of that, of course, is that you have a validation component. In other words, if there's something that doesn't meet those CAD standards, then you'll be informed of that, and then that feeds into the process as well. So why are we actually doing that? And let's go to the... So really, why are we doing this, or why are we using APIs, and why are we connecting those designs to programs in the field? So basically what we're showing here is a bid packet where we're taking it directly, natively into our own Triple Business Center. And what we're seeing here, if you're familiar with these types of designs, there's data loss there. Okay, we're losing attribution, we're not getting full solid objects, we're just getting a fragment, and we're getting some 2D data here as well. It's not translating across. If you're familiar with the process, this is very common, right? So the benefit of these APIs is we're able to prove that. So now on the left-hand side, we're looking at that full same design data, which was able to use those templatized conversion rules or APIs to read that data in all of the objects, all of the solids and structures. And now on the right-hand side, we're now looking at it from a contractor standpoint. And as you can see, that data set is significantly different to what we were just looking at. It's far richer. We've got solid objects, we've got attribution, and then that's what feeds into the process to go into the actual field solution side of things. So this is where we're improving the workflow, and this is how, by having a digital model as part of the process, how we're able to get better data to the field, better data to the contractor, which is a win-win for everyone. So why do we want to have connected? So of course we're just showing as far as taking the data from the design phase, but now we want to actually connect it to the field. And there's huge benefits that are associated with that. In other words, we can actually take those designs, we can ensure that the machines that are actually out there constructing the project are ensuring that they're using the latest designs, but it's also enabling us to be more accommodating of different changes. So if we find a design exception, or if we find an issue with the actual construction phase, we can go back to the office, we can update that design, send it remotely out to the machines, minimize downtime, minimize safety, or improve safety, I should say, because in the past, that design change would have had to be loaded onto a USB stick, driven out to the site, plugged into the machine, uploaded, not even sure if it's the latest design. That's the benefit of having this office-to-field connectivity, and that's really what those solutions are able to do. The other core component, of course, is being able to visualize that same data in the field. So we can have our high-accuracy positioning solutions visualizing the exact same data that's in the same object database that we were just viewing. So not only are we carrying all of those attributes across, but here we're now viewing that data in the field with all this. This is the same data that the machines are actually using to construct the project. There's attribution on those. We're able to visualize them with in this case, an augmented reality viewer called Site Vision. But like I said, the benefit of this is you can kind of consider it a model or a viewer into the data that's stored within the database, which is actually what is being pushed out to the field. And then from a contractor standpoint, and that's something we really like to focus on with Trimble, in that, you know, we've had contractors using digital models for decades, right? They've been recreating their own designs because historically they haven't got the right data in the first place. Or more importantly, they just haven't trusted the data. And that's the key benefit, I think, and this is resonating everywhere. I've been attending these IHEEP conferences for many years, and it's been great to really see the transition of understanding what the contractor is going to be using. They're the ones where the boots hit the ground. They're the ones that are actually taking that design, constructing it, and if we can improve it for them, then it's a benefit to the owner as well. Of course, a benefit to the owners, to the DOTs. It improves the whole process, and that's really where we're applying the BIM process. So here they're actually taking those same designs. This is what you see or what they're seeing on their mobile solutions, what the machines are actually using to construct the project, and then being able to use that as part of the validation as well. So what we can also then do, so we want to streamline the models, you know, basically for the field solutions. So one of the benefits of having the object-based workflow is when we read that data and using those APIs, everything gets associated with an object, with an attribute, with geometry. The best part about that is, or the key benefit of that is you can query that data then. So instead of having to look at a certain file, or we're not sure if you've got all, you know, you've got half of your objects in one file, half in another. Here what we're actually doing is we're able to look at each individual component, and that's very helpful to the contractor as well, because they're able to then segment that. They may want to estimate on the base of a retaining wall, for instance, because that's what they're being paid to calculate. So what we're showing here is effectively capturing that data, preparing it, streamlining it, and then utilizing this in the actual field solution phase. So what we're doing is we're improving it for the contractor to be able to take that, consume it, send it out to the machines, and then be able to monitor not only where it is, or make sure the machine's using the latest version, but then we're able to start to capture data back from the field. And that's really where we get into what we're calling intelligent digital as-built as well. So when they're actually constructing the project, you know, we're able to, this is what the contractors are actually seeing. And it's kind of important to be able to see that from a contractor standpoint. We are seeing that with many DOTs that are actually using, we're actually having the construction tools that the contractor are using to actually send the data, package it up, send it to the contractors, to the machines. Because it's important to see that in the design phase. Because if you can prove that, workflow, change your standards or deliverables to include contractor components, then that's where it provides them with more the ability to make sure that they're actually going to use that data, for instance. And this is what they're actually using when they're constructing it. Important point to note, of course, garbage in, garbage out. Here we've got a surface where, you know, there's a little issue with one of the side components. That machine, if that's not edited and cleaned up, this is what a contractor does. The machine, the blade will actually construct that. They'll put shadow in the blades and it'll actually create that in the field. That's the kind of information that needs to be fed to the design phase. Or at least if you can improve the components for the contractor, then this is the kind of error that they're going to be able to, you know, you're going to improve or minimize access, or minimize throughout the process. And then we talk about what we're calling intelligent digital as-built. So what does that actually mean for us? So yes, we're talking about connected data environments. The intelligent digital as-built is where we're starting to capture data back from the field. So we've got the machines out there, they're actually constructing the project according to those 3D designs. We've got all the blades on those machines are actually capturing data, surfaces, points. In this case, we've got surfaces in the bottom left-hand corner. On the right-hand side, we've got each of those little data points has an attribute associated with it. That could be a CV value, it could be a pass count. The value of having access to that information as part of intelligent digital as-built is, it really is important in the operations and maintenance phase. Because what that means then is, if you've got a section of road and it's constantly subsiding, there's an error there, there's some issues there, We could go back to the original data here, look at that, overlay that on the actual proposed and the existing, and then say, right, maybe this was under-compacted, maybe this was over-compacted. So that becomes part of the history of the project as well. And because that's then associated with an object within the database, we can constantly refer to that, we can query it, we can identify it. So that's where it's very, very helpful in the operations and maintenance phase. So how do we actually capture that data? And then how does that actually get, just to give you a very quick example of how that actually is captured. Here we're looking at progress mapping for earthworks while the project is being constructed. So we're now capturing those surfaces, or we're generating those surfaces, I should say. So what we just saw in the quadri database, or the object-oriented database, that data overlay, this is the source for that information. In other words, we're actually exporting that as a surface, because now we can actually start to do comparative analysis with that. So not only does it feed into the actual as-built phase, but it also works in the actual construction phase too, because I can monitor, okay, where is my proposed, where is my actual, and then I can look at my progress and be able to say, right, I need more additional equipment on site. These are the kinds of decisions that the contractor are making. So if they're able to get better access to the design data in the first place, and then be able to compare back to it as part of the process, then that's how you get this added benefit throughout the whole, even just through the construction phase. So this is now bringing that same data, and we're now going to overlay this on the original design data within Quadri. We're using now those same APIs that we were talking about, and we're overlaying that information all in the same place, and being able to visualize that within the database. And there's that surface. It's a little hard to see there, but you can see the triangles, the wireframe underneath. But that's an actual surface that's generated from the project itself. And that's now going to become part of the project history. So the traceability and all of that's built into the whole process. And then so, going back to what Ron was talking about earlier on too, with AASHTO, with pay item codes and things like that, what if we can now associate those attributes, those objects, or that attribution to the objects within the database? And that's essentially what we're able to do now with that intelligence. So here, we're actually having, this is a Caltrans template, for instance. We've got textures, everything matching their design standards, so back to those CAD standards we were talking about. Even the way that you visualize that data. And now we're looking at the AASHTO pay item code that's associated with that payment object within the database. So now you can, hopefully, building up a bit of a picture here, we're adding intelligence to the data. We're adding intelligence to that design model. So instead of just losing data each time you change between the phases, we're actually adding intelligence. So this is how you get to that true definition of the single source of truth. And even expanding on that too, what if we could take pavement condition analysis? So we could look at deterioration models using tools like Agile Assets, for instance, where we could run those models and then add that as that PCI attribute to the object, to the pavement object within the Quadri database. This is again how we're adding intelligence now. So we've got the AASHTO payable ID, we've got the PCI added to it. We can add that information into the process by using standard tools. We're not replacing any of these databases, we're just linking to those. That's the benefit of that API connectivity. And then of course, Ron talked about the IFC component, and that's a very important aspect. So I think being able to send those IFC objects out to the field is very important. So what Ron was showing with that awesome viewer that he was showing there, what we're doing here is taking that same basically that same concept. So we're taking aspects from the digital as-built, stored within that object-oriented database, with all that rich IFC attribution. Here we're looking at a utility network, for instance. We've got the intelligent objects that we're able to take to the field. Same thing, again, this is what the contractors are going to be doing once IFC adoption progresses. But the benefit, again, we've got that standardization. Everything is adhering to that schema, all of the attributes adhering to that schema. So now we're looking at the field solution that the contractors are using for surveyor. They're able to go in and look at the attributes themselves or look at the objects. These are the same objects that we're just looking back in the same database. And then we're able to query them, we're able to look at the intelligence on top of those, and then be able to see what that, how that feeds into the process essentially. There's all those IFC attributes that Ron was showing as well. Same concept here. So we're basically, again, this is how it's going to really help push the industry forward, because instead of having lack of information, no attributes, whatever, we've got, not only have we got attributes there, but they're all according to that schema, which, like Ron said, is, I believe, will be locked down by the end of this year or Q1 next year, according to buildings. And then, of course, part of our discussion was to partner with the industry, and of course that's why we have partnered with Infotech. And that was really where, our mobile inspector, or where we wanted to partner with Infotech for the mobile inspector side of things. And what was born out of that was really the concept of we needed to add, high accuracy positioning and essentially inspection data to the Ashleware component via mobile inspector. So instead of doing typing, writing down coordinates, things like that, by being able to add that field data capture component, we're minimizing rework, we're minimizing errors, and again, it's where this collaboration within the industry is really helping push things along. That's something we've been working on, and it's been expanded and received really well. And last, a couple of slides here, just to talk about that, final digital as-built. What does that actually look like? We talked about intelligent digital as-built. We talked about how we can capture all that data, how the contractors are using that information in the field. Now we're getting back to, okay, what about the operations and maintenance phase? And how can we have that rich data set as part of that? So we want to be able to keep those construction surfaces that we were talking about, that the contractors were creating, overlaying those, comparing those to the designs, or the proposed designs as well. Those 3D structures with attributes, according to those IFC attributes, the GIS, 3D utilities, for instance, and then being able to have those intelligent assets that we were just talking about. And then everything loaded back into that project history. And then last little video I just want to show you is what does that actually look like. So within that object-oriented database, we've got that same data that is being used to construct the project. And then we're able to start to bring in all these different data formats. So now we're looking at the point cloud information that's been brought in. We've got those 3D utilities. We've got full road corridors. In other words, those road corridors is what the contractors need to actually construct the project. So we've got that information in. We're able to add PDFs, we're able to add tabular data to the object within the database as well. And that's how we get to a true digital as-built, digital twin, whatever you want to call it, that has all of the project history as part of it. And then that's really where the industry is going, and that's where while we're partnering with everyone to actually, with Infotech to really push that forward. So that's really my part there, and we've got a little bit of time left for questions, I guess.
Question.
I think you were talking about the connected kind of environment. But does that assume that you're thinking about objects as the same thing? And does it get hairy if you've got 3.5 things here mapping to 5 things there? And particularly when you were talking about at the end, like linking with agile assets, I think a lot of what you were talking about is, for design, it may work because you've got a common concept. But when I go into agile assets, my concept of the road may be rather different. The way I break it up into pavement sections may be different from how I did construction sections.
Yeah. That's a really very valid point, because for agile assets, typically it's built on LRS, right? So that's part of the process that we're working with that database to be able to then translate that into objects within the quadrant database, for instance. So you're absolutely right. That's one of the challenges, because you're dealing with quite different, even spatial positioning, for instance, and coordinate systems. But that's one of the challenges we're working on. Yeah, absolutely. So,
yeah, and it even extends into the construction and design phase, because your pay items don't map one-to-one to your design items. So that is the challenge that we have. And one of the things that I look at is let's programmatically try to solve 80–85% of it and reduce the amount of manual manipulation you have to do to that mapping. One of the things that Triple demo for us is a project they're working on, where they are tying asset management through agile assets, and they're in between the design and the asset. There's a spreadsheet that they're using to be able to make this linkage. And when I saw the demo, I go, wow, we can't automate that spreadsheet. I mean, we need to be looking at that and make
so that can be checked. But that's unstructured. It takes a lot of horsepower to get that in there. Just wanted to, have you answer, what's the best approach that, using these tools, to integrate in APIs. In the field, you're limited with some smaller devices, small footprint devices. And then, I think the other thing is, in addition to that, federating, and you had near lossless, maybe you can share with, what are the kind of the challenges still in, federating these tools?
Go ahead. You can have that.
Thanks, Ron.
Yeah, I thought you were smart guy.
No, I mean, you're spot on. So even with the point cloud tool, so the question is really coming back to how do you federate the data and how do you utilize devices that may not be able to handle big point clouds and things like that, if I've interpreted it correctly, right? So that's where I think AI is significantly helping. For instance, some of the tools that we're developing and the industry is developing is the ability to segment that data and identify and extract actual features from those point clouds. Automate the process, but then be able to, at the moment, there's basic capability for there, but you'll see in the near future the ability to really go in there and map it all out and then be able to develop those individual objects, which then become objects within that object-oriented database that are much more easy to be handled by those field solutions. But that's a very, very, that's a very dynamic environment at the moment, simply because of the AI capability. But what we're seeing is what I've seen, it looks fantastic, and that's where we're really able to leverage that capability to generate objects and to generate things that are able to be used in those field solutions that do not have that full capability to load up full point clouds. And then even, for instance, we're partnering with Microsoft to be able to stream data from the Azure platform, so have the data sitting there. We have big entities like Caltrans that have massive data sets, or every DOT does. They're just simply able to be accessed. But what if we have those point clouds sitting on that Azure platform and then streaming just the components you needed? Again, tying back to segmenting what you need to as part of that process. So hopefully that answers that question.
Steve?
First of all, in your data standards there's a shameless plug for LandXML, which was created at an IHEEP meeting in 1998. So if you could add that, that's number one. Number two, when a machine is collecting as constructed data, is it on a grid pattern? Does it match the design points? Just explain how the data is collected so that it would be better used when it's brought back in.
No, that's a good question. So it's actually both. It depends on the machine. So, for instance, if you're looking at an excavator or a dozer, I mean, we have sensors essentially on both ends of the blade. So that entire blade is a surface, effectively, or when it's moving along, it's capturing the width of that blade. So we're able to then obviously composite that, and then actually, and of course, some of that data has to be filtered to generate that surface. So that's really the surface generation. The points that we were looking at, that's really, again, if you're doing a compaction value, that's more on a grid, because that's just the way they calculate things. So you certainly can configure the system to be able to generate that. So it is a bit of a combination of both. That said, even with those points, if you're using a particular attribute, say CV value, we could generate a heat map or ISPAC really based on exactly triangulating that and creating that. So you've got multiple ways of accessing that information. So that's a good question.
I want to go back to Steve's shameless plug. I sit in, as well as Andy sits in on a lot of the IRC meetings and things. And early on in some of the geometry definition stuff, they would pull up LandXML and look at the way that we define it in LandXML and use it as a historical source of what we need to be doing in that area. And on what Adrian just, to me, one of the pieces of information that we are really just shamelessly losing is all this automated machine equipment and capability that Trimble and other companies developing. They all capture information as they create that ground model out there. That is digitally captured. How many of you actually know that's digitally captured and have a process in place to use that as your digital as-built complete? And very few people are doing that. And it's there for the taking. And it's just shameless
here, I'm assuming one or both of those takes on the idea that attribution can be a post-process activity, and that you're able to basically, you're setting up attribution, it's not getting crammed into the data model of the IFC or whatever else, it's using maybe object IDs or something to link attribution back to the physical model. So,
Well, it's, yes and no, okay? In the connected environment, and that's one thing I really want you to come out here and start thinking about connected, not common, okay? In the connected environment, you should leave information where it belongs and use data governance to protect the data for the right people, the right time, and the right place. Some data you will want to, as you say, cram it into the IFC model. Some data you need to leave with the author of the data and protect your data provenance in that case, okay? And so it is some of your data governance that you need to develop within your organization, how you want to do that. Some of it is just people like us working together and say, are you the owner? I'm the owner. And try not to duplicate data if we can keep from it, because that's when we get inefficient and we get inaccurate, is when we duplicate data and it only gets changed in one place. So that's still a challenge that we're working on, but I think it's about to.
Yeah. What about the incorporation of reality mesh? You had mentioned that. You know, there's obviously you're not going to model 1,000 trees, but you know they are picked up during the scans and generated reality mesh. Have you thought about integrating that through your API, or are you there yet?
So, I mean, yeah, so as far as the, where I know that the industry is working on that. I mean, if that's coming from a point cloud, that really ties back to the extraction from that point cloud to generate those objects. I think that's really where you would get to that. You know, we're working more on the, you know, really being able to better utilize those point clouds, really just to translate into objects. That's kind of, that would be our component. I know there's other players in the industry that are certainly working on using those meshes. I mean, hopefully that kind of answers the question, but it's more just extracting what you need to for going back to what Ron was saying. Yes, it's great that we do with reality mesh, but if you only need certain components of it, and then if we can read attribution from that or add those to objects within the database, then I think that's where it becomes more useful.
That's another question. Any other questions?
one more quick one. In your API plugin slide there, you had mentioned bidirectional.
Correct.
So how are you pushing design changes back into a design authoring tool like OpenDocs?
So I'm always very careful about saying that too, because you don't want to, you do have full control over that, of course. Now what that may mean, let's say the contractor comes across a design exception or something in the actual design phase, in the construction phase. Technically, what you can do, you could push back from Triple Business Center into the actual, via those APIs back to OID, push that design, maybe it's an additional element, a modification. In that case, it's probably going to be something like a constructability change. Let's say a vertical, if you're familiar with the way that machines work, they can't handle vertical surfaces. So what may happen there is if you bring it into Trimble Business Center, for instance, it gets flagged and says there's a section here with a vertical surface. What it ends up doing is just slightly shifting it, you know, very, very minor distance. It removes that vertical surface, and then the machine can actually construct it. Whether or not you want to push it back, you could. That capability does exist because of those APIs. Those conversion rules that we were talking about, they're bidirectional as well. So that's how it's able to read that change and push it back into the native software. So, but you have got full control over that.
I can see that to believe that.
Well, it's a discussion.
I'd love to say it.
Yeah, there's a discussion that we're having with a couple of the owners, because when you start getting that as the information, is it information that needs to go back design? Is it serious enough that it needs to go back design? Or does that information need to go to asset management? So which way do you need to push that? So which way and which direction is that connection? And that is, you know, really gets down kind of a discussion between the owner and the engineer as to how serious we change it.
Well, leads us down the path, because we still don't know what an as-built BIM model looks like, and
Thank you.
I guess